All right, this video is going to debrief the activity, how many rubber bands does Barbie need? So hopefully you got values similar to what I have here in the table. I know we watched the video and it was slow-mo, but we kind of had to estimate how far each dinosaur dropped for every set of rubber bands. But I got, like 9 centimeters for the lowest distance and like about 108 for the longest distance. Okay, so let's start with question number one. Identify the explanatory and response variables. So the explanatory variable is the number of rubber bands, and the response variable is the distance traveled. Okay. Think of the explanatory variable as the thing that you're using to make predictions. You can also think of it as like the input values. And then the response variable you can think of as the final outcome, the final measurement of the study, or think of it as the output values. Right. So what's the input? What's the output? All right. Question two, we've got two quantitative variables. So number of rubber bands is measured numerically, so it's quantitative, and distance traveled is measured numerically in centimeters, so it's quantitative as well. All right, in question three, we've got a scatter plot. Number of rubber bands is the explanatory variable. We put it on the horizontal axis. Distance traveled, the response variable, goes on the vertical axis. All right, let's go ahead and make a note of that. So this is our explanatory. And this is our response. Right. And it will always be constructed this way. Okay? Explanatory goes on the x-axis. One kind of mnemonic device you can use to remember it. Response variable goes on the y-axis. All right, here's a pretty simple description of the relationship, right? So the dots here have an increasing pattern, and they're very tightly aligned with one another. And so they form a nice straight line. Now, College Board is expecting a little bit more as far as describing the relationship. And we're going to use a new acronym to help us write these types of responses. The acronym is DUFS. And each letter stands for a different characteristic of the relationship. So the D stands for direction. Okay. The U stands for unusual features. Unusual. F stands for form, and S stands for strength. All right, so here is a a, a model response for like an FRQ question, right? So we might say something like, there is a strong, positive, linear relationship between the number of rubber bands and the distance traveled. There are no unusual features in this scatter plot. All right, so let me underline the key components of this response. So I mentioned that the relationship is strong, so that's the strength. I mentioned that it's positive, that's the direction. I mentioned that it was linear, that's the form. And then we said that there's no unusual features, there's no points that kind of fall out of the pattern, there's no huge gaps or clusters or anything like that. Another key ingredient in this response is the context. So I mentioned both the explanatory variable and the response variable in this solution. So that's another thing here, is that we need to include context in addition to the UFS, direction, unusual feature, form, and strength. All right, so to quickly summarize, in this lesson, we learned a new type of graph for displaying relationships between two quantitative variables. So our scatter plot, remember the scatter plot is going to have the explanatory variable on the x-axis. Let's open this up again. So always label the explanatory variable here, and then your response variable goes on the vertical axis. And you'd plot point for each ordered pair, I guess, that you collected data on. All right, the second big idea here is, how do you describe that relationship? What are the key components that you need to have in the response? So remember the acronym DUFS. So that's direction, unusual features, form, and strength. Okay. Now, as far as direction is concerned, you're going to see some scatter plots that show a positive relationship, some that show a negative relationship, and yet there's going to be others that kind of have a random pattern, so there's really no relationship. All right. What sort of things should you be on the lookout as far as unusual features? So definitely outliers. Right? These would be points that don't really follow the pattern, okay? As well as like clustering, right? Groups of points that cluster together. All right. For form, you only really need to identify two types of forms. Okay? So a linear form, like what we saw with the bungee jump data, as well as nonlinear forms. Okay. Now, nonlinear captures a lot of different things. It captures like exponential forms, quadratic forms, trigonometric forms like sine and cosine waves. Really anything that's not linear. You don't have to specify what type of function it looks like. You just have to say it's nonlinear. Okay, last is the strength. So the strength refers to kind of how close the points are to that form. Right? So if the form is linear, how close are the points to forming a line? If the form is kind of looking exponential, right? How close are those points looking to an exponential growth curve? All right, so I'm going to end the video here. You guys can work in your groups on the check your understanding question. Answer key will be posted on Canvas later today or tomorrow.